Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 27, remove element. This is an easy level difficulty Leetcode problem, and the problem description tells us that we're given an integer array called nums and an integer called val, and we need to remove all occurrences of val in nums in place, so we can't modify the array. We need to manipulate this array in place, and the order of the elements may be changed, and we need to return the number of elements in num which are not equal to val. And we're told that consider the number of elements in nums which are not equal to val to be k. So basically our integer array nums, if we were to remove all occurrences of val, the length of that new array would be length k. And to get accepted, we need to do the following things. We need to change the array num such that the first k elements of nums contain the elements which are not equal to val, and the remaining elements of nums are not important, so we don't need to worry about what they actually are. And then we need to return k, which is going to be the, like we said, the length of array nums where we have removed all occurrences of val. And we're told that this is the custom judge, and you can look through this judge, but it can complicate things a bit because you're like, okay, what's this judge doing, and how does the assertion actually work? But it's simple. We're basically given an input array, a value to remove, the expected answer, and then we'll look to make sure that the judge will look to make sure it's sorted with no values equaling that value, and then it'll call out implementation, and then basically assert that we have the correct length, or such that k is equal to the length of the list where we have no occurrences of val. But what kind of helps for me when solving these kind of Leetcode problems is looking at the example. So in this example, we're given 3, 2, 2, and 3, and the value is 3. So we're told that our function should return k being 2, because of course value is 3, so we want to remove all occurrences of 3, and that will just leave us with 2 and 2. Of course, those 3's have to go somewhere. We are removing in place. We're not manipulating the array, so we're told again it does not matter what we leave beyond k, which is why the underscores here. But of course, these are 3's, and so we want to just return the length of 2 and 2, which is going to be equal to 2. And we're given another example here. And so how can we solve this problem? Well, the most intuitive way to solve this kind of problem is using a two-pointer solution. I'm kind of going to go over this. We're going to have 2 pointers at either end of our list. So we've got 3, 2, 2, 3. We've got a pointer at 3 at the beginning, and we've got a pointer at 3 at the end. So what do we do here? Well, we say, is 3 equal to val? Is the left pointer equal to val? Yes, it is. So we're going to swap 3 with the value at pointer r. But in this case, we're still going to get 3, 2, 2, and 3 because the value at pointer r is also a 3. But now we're going to shift our right pointer such that it equals the value at the right pointer equals 2. And so we're going to swap 3 and 2 around, so we're going to get 2, 2, and then 2 basically. So 3 and 2 are going to be swapped around. So and we'll keep on doing this until our pointers meet each other, at which point we will return k, and what will k be? K will be r plus 1. It will be our right pointer plus 1, because Python is zero index based language. So that's the core logic of how we're going to solve this problem, and it'll make more sense as we actually start writing the code. So let's do that. Let's set our left and right pointers equal to 0 and the length of nums minus 1. I'm going to say while L is less than or equal to R, if nums L is equal to the value that we want to remove, we want to say nums L is equal to nums, or we just swap the values, but we don't need to worry about any of the values after the k for first element, so we can just swap them directly like this, and then we can say r minus equals 1. Otherwise, we want to, if the value is not equal to k, is not, or the value at the left pointer is not equal to the value that we need to remove, well, we'll just increment our right pointer by 1, well, left pointer by 1, sorry. And then we want to return, like we said, r plus 1, which is going to be equal to k. So let's run the code. And we get the wrong answer. Why do we get the wrong answer? Well, let's look at our code. This is learning experience. So length of nums minus 1, nums L equals val, nums L. Okay, this should be equal to, not a comparison, but actually setting the value. And there we go, 116 test cases passed. And we have quite an optimal solution. It passes 100% of other solutions. This is not always accurate, but it does give us a good indication that we have an optimal solution with this two-pointer solution that we've written here. So in terms of time complexity, guys, we're looking at an O of n linear time complexity. Space complexity is going to be O of 1, a big O of 1, because again, we are modifying in place. This is the keyword for today. And with that being said, I hope you guys enjoyed this video and the solution made sense, and I'll catch you in the next one.